We'll calculate by hand some AR1 forecasts for some real data. Recall in the last video, we looked at the model for an AR1 and considered the forecasting formula for such a model. So let's go back and look at that. Just remember that the formula for the AR1 model is given by x sub t minus phi1 times x sub t minus 1 equals 1 minus phi1 times mu plus a sub t. Now notice that this can be written in operator notation form, and that would look like 1 minus phi1 times b times xt minus mu equals a sub t. That's important to notice because for this particular example, I'm going to show that the data is generated from the model that's in that form. So if you were to FOIL this out, you would actually get this back as well. So it's the same thing. Now, for our example, let's suppose that we have 80 data values that are generated from the AR1 model given by 1 minus 0.8b times x sub t minus 25 equals a sub t. So it looks like this form of the model. We can tell that phi1 must be 0.8 and that mu must be 25. Furthermore, suppose that in this data set that x80, that's the 80th data value, turned out to be 21.77, and x bar, the sample average, is 24.17. Now these data can be seen in the TSWGE file, fig for figure 6.1 NF meaning no forecasts were there previously, and that's the goal of this, is to create forecasts. Now, another thing that we need to remember is that in our last video, we established the formula for the forecast function for an AR1, and it looks like this. X hat of T naught of L equals 1 minus phi1 times X bar plus phi1 times X bar T naught of L minus 1. And we looked at the iterative procedure on how that is calculated, but we didn't use actual data. And in this example, we want to look at actual. Using this forecast function, along with the fact that we know that phi1 is 0.8 and that x bar is 24.17, we can substitute and write this as 1 minus 0.8 times 24.17 plus 0.8 times x hat of T naught of L minus 1, which turns out to be 4.83 plus 0.8 times x hat of T naught of L minus 1. Now our T naught we know is going to be 80, so I'm going to go ahead and put 80 in here of L minus 1. And that is our general forecast for this particular AR1. Now, let's calculate forecasts for the 81st, the 82nd, and the 83rd values of this data set using this formula. We know it's an iterative procedure. We've got to go in order. So we know that if we're looking for the forecast for the 81st value, that would be x hat of 80 of 1, which is given by 4.83 plus 0.8 times x hat of 80 of L minus 1. Well, L is 1. 1 minus 1 is 0. And that gives us 4.83 plus 0.8, and we know that x hat of 80 of 0 is really the same thing as x of 80, which is the data value that we have. And x of 80 is 21.77. And that gives us a value of 22.25. And that's the forecast for the 81st value. What about the 82nd? X hat of 80 of 2. Using the general formula, will be 4.83 plus 0.8 times x hat of 80 of L minus 1. Here my L is 2. 2 minus 1 is 1. Which we can write as 4.83 plus 0.8. Well, what is x hat of 80 of 1? Well, really, that's the forecast for the 81st value, which is what we calculated in the step before. So we'll here have 22.25. When we calculate that, we get 22.63. And then, for the forecast for the 83rd value, that would be x hat of 80 of 3, which is 4.83 plus 0.8 times x hat of 80 of L minus 1. That's 3 minus 1, which is 2. That will give us 4.83 plus 0.8 times x hat of 80 of 2 is the forecast for the 82nd value, which is given in the step before, of 22.63. And when we calculate that, we get 22.93. So these are our forecasts for the 81st, the 82nd, and the 83rd values. Now, one thing that I would like to say before I leave this example is you may be wondering, why did we choose to use x bar of 24.17 when in this particular case we knew mu, we knew that the population mean was 25, so why did we settle for using x bar? Well, obviously in real applications we're not going to know the population mean, so we in this example thought it would be best to go ahead and just use x bar, which comes from TSWGE, which is the sample mean of the data. So that's why we put in 24.17 instead of 25. So this is a neat example of showing how the forecasts are calculated for an AR1 when using real data.